Our next presenter today is Dr. David Diamond. He is a senior ecologist for the Missouri Resource Assessment Partnership at the University of Missouri. He began his career as a heritage program ecologist for Texas, where he wrote the first modern classification of the vegetation of the state. David?
Well, I have to follow Steve. Somebody had to do it. But here we are. Here we are in Austin. We're sitting on the Austin Formation, just off the Edwards Plateau. The Mount Bunnell Fault is on the other side of MoPac. So we're on kind of the Blackland Prairie, the former Blackland Prairie. And I'm going to talk about vegetation patterns of the Edwards Plateau because if you look at Ashe Juniper, the range of Ashe Juniper, it's not a very widely distributed species. It's certainly not dominant over much area, but it's very important here on the Edwards Plateau in parts of it. So I'm going to talk about the vegetation patterns of the Edwards Plateau. So where are we again? We're here in Austin. We're here just off the southern end of the tall grass, mixed grass, short grass prairie continuum. And the precipitation is reduced to the west across that continuum. Again, we're just off to the south of that. You can see a little bit of a bump out in the annual precipitation here in the southern Edwards Plateau. And if you look at tree density from U.S. Forest Service, you can see there's a lot of trees here in the southern part of the Edwards Plateau. So that's kind of where we are in North America, or in the United States anyway. But let's zoom in. These are the level 4 ecoregions of the Edwards Plateau level 3 ecoregion. So there's 4 subdivisions. The Llano uplift there is a geologic uplift, but it's a topographic basin. And it's underlain by acidic materials, ancient acidic materials, and there's very little juniper over those acidic materials. So that's why that subregion is segmented out from the others. All of the green areas are underlain by limestone, mainly lower Cretaceous limestone. But why the segmentation of those 3 regions? Well, as I said, the precipitation is reduced to the west generally in North America, in the Great Plains. But in the Edwards Plateau, there's a precipitation increase to the south and in some places to the west. So that kind of bucks the trend of reduced precipitation to the west. So why is that? The Balcones Canyonlands region there is the wettest region of the Edwards Plateau, and then the Edwards Plateau woodland region is intermediate. So why is that? Well, this is the elevation, and areas with the same color are the same elevation or in the same elevation zone. So that brick red is really wide up in here. So that's a gentle landscape. There's not a quick elevation increase. There's really very little brick red down here. That's because there's a real rapid increase in elevation along the Balcones Fault Zone there in the southern part of the Balcones Canyonlands. In fact, 1,000 feet of elevation in only a half a mile. So what you have is you have breezes. The prevailing winds are from the southeast across the Gulf, across those plains to the south of the Edwards Plateau, and then the air masses hit the mountains right here. They rise. Cool air holds less water than warm air, so it rains. This is an orographic effect, which is common throughout the southern Rocky Mountains, really throughout the world. So that's why it's so wet in the Balcones Canyonlands. The other thing about the Balcones Canyonlands is it's rough. These are slopes in gray. They're slopes greater than 20%. And you can see, in general, the Balcones Canyonlands is pretty rough. It's rougher than the Edwards Plateau woodland, which has also got some roughness to it, especially associated there with the Llano River drainage. This not rough area in here sometimes is called the El Dorado Divide. At least Keene Ferguson called it the El Dorado Divide. So the Ashe's juniper woodland is concentrated in the Balcones Canyonlands because it's wetter and rougher, and there's very little Ashe's juniper woodland to the west because it's too dry for Ashe's juniper out there. So let's just zoom in right here. This is the pink, the dark pink is Ashe's juniper shrubland. The green is Ashe's juniper woodland, not very much of it. The light pink is deciduous shrubland, and the yellow is grassland. So as you go west, there's less woodland and there's less Ashe's juniper. And in fact, during drought years, this was a drought from about 12 years ago, Ashe's juniper does die in drought, and it's only moderately drought resistant in the grand scheme of things. So now let's zoom down into the Balcones Canyonlands. Steve said this is the main area that we want to talk about. So this is a summary of the land cover, the vegetation, the Balcones Canyonlands. It's more wooded with woodland and shrubland than it is grassland. So 41% woodland, 27% shrubland, and only 21% grassland. There's also substantial amounts of urban land in this ecoregion. And urban land has doubled in the last 20 years due to the growth of Austin and San Antonio mainly. And of course, the sloping areas are much more wooded than the flat areas. So it may look something like that in this Balcones Canyonlands region. A lot of slopes, a lot of canyons, a lot of woodland mixed with ash juniper and deciduous woodland. So now let's scope down again to more of a local level. There's a lot of variation in the vegetation due to variation in the landform, geology, and soils. And so the plateau tops are different from the steep side slopes, which are different from the valley bottoms. The north-facing slopes tend to be a little wetter than the south-facing slopes because the sun is in the southern sky in the northern hemisphere, so that the south-facing slopes get more sun. They're a little drier. There's a lot of variation even in gentle landscapes due to the differences in the underlying geology and the erosion that has taken place. This redland type here is a very interesting type. It's sort of sporadically mapped in the soils maps. It's not consistently mapped, but it may be an ancient soil from back in the Holocene even. But there's a lot of variation due to the landform geology and soils, and I think that tends to be overlooked. You can really see variation due to land management, like in a fence line contrast where one manager has cleared the woodland and the other manager has left it open. You really see that. You don't see this as much, or a lot of people, I think, don't see it as much. This is an overhead look at that. You can see the canyons here are heavily wooded. This gentle upland right here has alternating bands of more open vegetation, grassland, and woodland. And that's because the underlying geology is wetter or drier. So the woodlands are growing on the wetter part of the landscape, which is associated with different layers of geology. The vegetation doesn't cause this difference in what moisture availability. That's occurred across a very long time period due to weathering of the underlying vegetation or underlying geology. So this whole area that I've circumscribed there is a single ecological site type.
It's called Low Stony Hill, and it's a single mapped geologic type in the 1 to 250,000 Bureau of Economic Geology maps. It's an Edwards limestone Fort Tarrant member. But you can see there's an alternating grassland, shrubland, woodland component here in this landscape. And it's because we're in that area that transitions from woodland to grassland because of the precipitation in the Balcones Canyonlands. So there's a really great paper that talks about the stair-step topography and the alternating habitats, geophysical settings in the Glen Rose slopes by Woodruff and Wilding, and we're lucky to have Chalk Woodruff in the audience today, so you can ask him about how this develops. Hint, there's no marl. There's no marl involved. And again, this, whoops, let's go back. This alternating, stair-step topography and wooded versus grassy habitats due to the geophysical setting differences is the rule in the Edwards Plateau, not the exception. This is very common. So now I'll go to the vegetation that's in the Edwards Plateau. Something I wanted to point out, this is from the Texas Parks and Wildlife Department Landscape Ecology Division. This information is all posted on their website. There's a lot of live oak, those two top things here. There's a lot of live oak here, and there's also a lot of deciduous shrubland in the Edwards Plateau. And those things are not mapped in the national data sets. So that's a pretty big drawback, not to map the live oak and the deciduous shrubs. There's also variation east to west and north to south that I'm not going to go into. There's short descriptions on the Parks and Wildlife website. And there's also things like this. This is the longer description of the ecological system. It gives the geology, the soils, and the landforms. The soils include the ecological site types that they're mainly on, and then the vegetation. And there's a range map of where the type is mapped. And I'd like to point out that the Ashe's Juniper extends up into the Lampasas cut plain on Cretaceous limestone. This area here is the carbonate cross timbers. It's Pennsylvanian and Cretaceous limestones. It also has similar communities, and it has Ashe's Juniper. So vegetation pattern summary. Gets too dry for Ashe's Juniper out west on the Edwards Plateau. The Balcones Canyonland region here is the wettest part of the Edwards Plateau. It's also very rough, therefore it's the most wooded part of the Edwards Plateau. And the Edwards Plateau transitions from mainly a woodland, or mainly wooded vegetation, to mainly shrub and grass vegetation to the west due to precipitation gradient. There's a lot of variation locally due to landform geology and soils. It's apparent from the air. If you were standing on the ground, you wouldn't be able to see it very well because all you could see is the canyon, for example, and the first woodland upslope from you. So it's not as apparent as fence line contrast due to management. So that's the vegetation summary. I'll take a shot at pre-European vegetation patterns. First of all, they're unknowable in any quantitative sense, and it was probably very patchy and diverse, and it's easy to overgeneralize, which I'm very aware I'm going to do. But most steep slopes were wooded, I think, and they were protected from fire for decades or maybe centuries. They were so mesic. Uplands were likely a mosaic of woodland, shrubland, and grassland. I personally am going to say it was mainly a woodland because of the precipitation, the precipitation gradient. And the major woody components back then, I think, was Ashe's Juniper, Texas live oak, Texas red oak, and shin oak. And I haven't changed my opinion back when we wrote this some years ago.
We modeled the historic vegetation and compared that to the current vegetation, and I didn't think the land cover had changed dramatically since European settlement, and I really still don't. The most significant invasive species, I think, is king ranch bluestem, although there's a lot of Bermuda grass pastures out there in the lower parts of the landscape. Chinaberry is becoming an invasive in more mesic areas, and in urban areas, there's quite a lot of pistachia and ligustrum and other species getting into the woodlands from the urban areas. I don't think I would have said that there's not a dramatic change anymore because of the urbanization. Urban area has just about doubled since we did this paper. So urban is a very important, it's the thing that's different. There's not much cropland, there's not much lakes. There's more urban than anything else in terms of destroying the native vegetation. So I'll talk just a bit then about management. You'll hear from the Charles and Brian, I think, later about ecological sites and ecological site descriptions. The major land resource area that corresponds to the Balcones Canyonlands is called the Edwards Plateau eastern part. You can go to this website and get the ecological site descriptions. There are 12 ecological sites mapped on the Edwards Plateau. Obviously, they have to be very generalized because there were 19 communities that have more than 100,000 acres of area on the Edwards Plateau. So, and I'll give you this as a reference, a paper reference here. You can go get that. A lot of good information in the ecological site descriptions. They're 25 to more than 30 pages long for all dozen of them that exist for this MLRA. This is one thing that's in there. It's the state and transition model. I think I take this with a little bit of a grain of salt for two reasons. One is the mapping. The ecological sites as mapped by the soil map units are very diverse within them. Remember, I showed you this, how it alternates really between woodland and grassland within that single ecological site. So, and then there's also discrepancies in the overall mapping, it's inconsistencies by county. The other thing is, I think that the herbaceous component of the vegetation is overemphasized in the reference site here. I think parts of it were more wooded than is stated here. But anyway, the ecological site descriptions are there. They're very, very excellent. Tremendous amount of good information in there. This is the other part that the soils mapping has problems with. This is the Balcones Canyonlands, the Llano Uplift, and the Edwards Plateau woodland ecological sections. And those things that are circled are county line discrepancies and in mapping. And when I first saw this, I thought, well, I'll just change the coding and everything will be fine. I'll make it match. You can't do it. I've tried, we've done statewide mapping in Texas, Oklahoma, Nebraska, Kansas, Arkansas, and Missouri, and you can't do it. So you can't fix this. Nonetheless, the soil polygons are very good at circumscribing at fine resolution things like deep sands, saline, perched water tables that are not available in any other data sets. There's helpful new geophysical setting information that has been developed. A lot of this stuff is developed by analysis of digital elevation models that weren't even available when the soils maps were done. The soils maps were done a long time ago. The LiDAR-based digital elevation models have only been available for just a very few years, and they can be analyzed, and the geophysical data, geophysical setting information extracted from those digital elevation models. I'm not going to go over all of these, but they're beautiful. They can be very lovely, and they very much conform to the landforms. The red areas here, this is a flatter area. This is a more rugged area. This is the Balcones Canyonlands. This is the Edwards Plateau woodland. The red areas there are wetter, and that does have an influence, so that will influence the current vegetation and the response to management of those areas. So this is really great information. I think the problem is that it's not really accessible to land managers, not all of them anyway. And the other thing, it's not interpreted. For example, what does being red in this image mean in terms of the potential vegetation and response to management? That kind of stuff is summarized in the ecological site descriptions. It's not summarized for some of these data sets. We could do a project and make these data sets available for managers and planners. That would be a good thing to do, I think. One thing, though, it will not get us to the variation in the underlying geologic geology and soils. So those don't necessarily conform to the landforms, and these data sets conform to the landforms. So it won't get us everywhere we need to go. And I'll leave you with this. Climate change. I haven't talked at all about climate change. We do know it's happening. We do know it's getting warmer. We're not sure how that will influence the precipitation or the drought cycles. But I will say this, Ashe's juniper is not particularly drought tolerant in my view. I know that sounds weird to say, but it's not a very deep-rooted species. It colonizes open areas, whether they're wet or dry, if the precipitation is high enough, but it will die in drought. So I would say the woodlands, since we're in an area, the Balcones Canyonlands is in an area that transitions from woodland to grassland. If it gets, drought becomes more important, there'll be less woodland in this region, but I don't know if that's going to happen. Please, my email is there associated with this talk. Later on, next week or whatever, if you want to email me, we can set up a Zoom. We can look at some of these data sets and talk more if you want. And Steve said I should put aside all of my biases, which I haven't done. So I feel really bad about that. It's like, what the hell can I even say after Steve was talking? I can't even say anything. But my biases, I come by my biases based on a long history of looking at the ecology of the region. So anyway, I think that's it for me. I wanted to avoid this, but I didn't talk long enough. Anything?
Any questions for David?
No, not from Steve. Okay, go ahead.
So the alternating bands of vegetation that you described on the uplands, the low stony hill,
Yeah.
is that due in part to some of that bedrock is fractured and some is not fractured?
Exactly. That would be my view. The fractured bedrock has more soil moisture availability deep, and the woody vegetation is taking advantage of that. Yeah, that's what I think. I know a lot of you just wonder if I was still alive, so if that's a question, yes. Anything else?
Thank you for a really cool presentation. So you talked about your opinion is that the uplands were probably a little bit more wooded because of the rainfall. What do you think the role of fire was in shaping what the landscape looked like?
Oh, that's easy. I don't know. You know, and I don't mean to be flippant about that. Usually fire histories are based on looking at deciduous trees across time, and there just is not, I could not find a fire history, a good fire history. There may be some out there, you know, post oak doesn't grow very many places on the Edwards Plateau because it's mainly restricted to the redlands soils, which are not that abundant. The question is, was there enough fire to keep Ashe's juniper out of the upland woodlands? I'm pretty sure the uplands had a lot of woodlands. I just don't know how much Ashe's juniper was in it, and I don't think anybody does, but that's just me. There are junipers in the mountains throughout the southern Rocky Mountains. Fire has not kept them out.
Right. Thank you. Let's give David another round of applause. Thank you, David.